Anaerobic digestion is the biological conversion of biomass to biogas and a stabilized slurry called digestate in a warm, oxygenless environment. Biomass, a general term for organic materials ranging from food waste to grass clippings to animal manure, consists of complex, large organic compounds that are broken down into simple organic materials during anaerobic digestion. A large community of naturally occurring microorganisms are used to carry out the process and convert the biomass into biogas. The process of anaerobic digestion can be compared to the biological process of how the stomach of a cow breaks down food. Anaerobic processes use available organic matter and are catalyzed by intra- and extracellular enzymes. Anaerobic digestion begins with hydrolysis, which is the breakdown of carbohydrates, proteins, and lipids into monomers such as amino acids, sugar, and fatty acids. The second biological step is acetogenesis. This process converts monomers into bicarbonates, alcohols, hydrogen, and organic acids through fermentation. Acetogenesis then oxidizes these alcohols and organic acids to hydrogen and acetate. Methanogenesis, the final biological step, forms methane from the hydrogen and acetate. During this process, the biomass is stabilized, mineralized, nutrients increase, and pathogens, odor, and total solids are reduced. The main goal of anaerobic digestion is to stabilize biomass so that it can be used as a nutrient-rich fertilizer and in the process create biogas, a renewable energy source. Biogas is a mix of methane, carbon dioxide, moisture, and trace gases. Typically, the methane content of biogas ranges from 50 to 70% depending on the biomass input, commonly called feedstock, and the digester operating conditions. Hydrogen sulfide is a common trace gas of concern for manure digesters due to its corrosive and toxic properties. Biogas is used directly as a fuel source for the generation of heat, hot water, steam, or electricity. If refined and compressed, biogas can be used as renewable, compressed, or liquid natural gas. Digestate is made up of mineralized nutrients including nitrogen and phosphorus as well as undigested organic matter and water. The digestate can be separated into solids and liquids. Solid digestate is often used as animal bedding, compost input, or directly as a carbon-rich soil amendment. Liquid digestate contains most of the soluble nutrients and is used as a liquid fertilizer. There are numerous parameters to take into consideration for designing an anaerobic digester. Volume, temperature, retention time, and mixing are some of the key parameters. Understanding the planned feedstock characteristics is critical for designing these parameters. pH, carbon to nitrogen ratio, the total and volatile solids content are also important for determining the feedstock blend and maintaining a healthy biological system. Solids content of the feedstock drives the selection of the digester type. Daily flow rate of material determines the digester volume. Optimum temperature of the system varies based on management goals, regulations, digester type, and feedstock composition. There are two main temperature ranges for anaerobic digestion: mesophilic, which ranges from roughly 90 to 105 degrees Fahrenheit, and thermophilic, which is between 115 to 130 degrees Fahrenheit. Retention time mainly depends on the temperature, waste composition, and desired level of waste stabilization. Mechanical mixing systems are used to improve contact between microorganisms and feedstock, prevent the settling of scum formation, and maintain a uniform temperature. General guidelines for maintaining healthy anaerobic digesters includes maintaining pH in the optimal range of 6.4 and 7.8. The carbon to nitrogen ratio of the digester feedstock should be between 20 and 30. Finally, effluent volatile fatty acid levels should be less than 300 parts per million. A wide range of feedstocks can be used in anaerobic digesters. Some examples are dairy manure, domestic wastewater, and food waste including fats, oils, and grease. In general, feedstocks should not contain toxic or antimicrobial components, heavy metals, or inorganic materials.